This is the ITO film used for bending test. It has already printed 2 electrodes on the ITO coating side and guided it to the pin by the side without ITO coating. So, if we apply a DC voltage on the pin, it will construct a uniform electric field in this direction. This is the DC power supply we used in the test. The positive and negative electrodes of power supply are connected with 2 pins respectively. The negative electrodes of 3 multimeter are connected with the negative electrode of power supply. The positive electrodes of 3 multimeter are connected with the ITO coating of the film through copper sheets. Copper sheets are used to improve the stability of connection. So, these 3 multimeters can detect the voltage of 3 points. We applied 0.5 volt voltage to the ITO film. The multimeters are tuned to the DC voltage and opening the power supply output. It can be seen that the multimeters have measured the 3 points voltage of the ITO film in the natural state. I can pick up the ITO film for bending test. When the ITO film is bent, it can be seen from the multimeters that the voltage changes at these points are very small. The reason for the change may be the poor contact of the copper sheet. In order to eliminate the problem of poor contact, we connect the probe of multimeters to the pin of ITO film directly for resistance test. To prevent the electrodes from contacting each other during bending, we firstly cover the electrodes with tape. The electrodes have been affixed with tape now. We switch the multimeter to the ohm. We can see the sheet resistance of this ITO film is 176 ohm per square. The inconsistency with parameters given at the beginning of video may be due to the non-standard fabrication of the electrodes. But this does not affect the sensor operation because the sensor operates on the detection voltage. We can see that the resistance measured by the multimeter is almost constant under normal bending conditions. So let's test the critical bending radius of the film. The side with ITO coating should be on the opposite side of the bending, because its resistance changes most easily in this manner. Considering of the direction of the electric field lines, we should bend perpendicular to the direction of the electric field lines. Attention to observe the change of resistance during bending. When the bending reaches a certain level, the resistance starts to increase. We think that when the resistance reaches 180 ohm, the ITO film has reached the critical bending radius. At this point, the minimum distance between 2 points on the hole is measured 12.9 millimeters. We have a screenshot of the video at this moment and import the picture into the SolidWorks, measured a minimum distance of 78.02 millimeters, so the picture should be minified by 6.06 times to restore the true value. We plot the perimeter of the hole with a spline curve, then analyze the minimum radius of curvature of the spline curve is 4.32 millimeters, that is, the critical bending radius what we want of the ITO film.